Welcome back. This is a quick tutorial on section 1.4.4 complement of sets. So the complement of set A contains everything that is not in set A. You can represent your complement in a couple of ways. One is you can say, let me move the cursor. You can, let me just see, you can say a complement, which is A and C on the top, or you can say A with the hyphen, or you can denote it with A and a bar on the top. Some textbooks also have it as not A. So it depends on which textbook you are, but all of these do represent complement of a set. So let's go ahead and work some examples so you can understand this better. All right, here it says, consider the set U. So here we have a set U, and set U is natural numbers. Let A be a set consisting of multiples of 6. Which of the following numbers is not a part of complement of A? So here I have a set U. It's all natural numbers. So I have 1, 2, 3, 4, so on and so forth. And then I have set A. Set A is multiples of 6. So 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, so on and so forth, right? What are they asking me? They're asking me A complement. So something that is not in A. So A complement is something that's not in A. So when I look at it, A complement, which of the following numbers is not a part of A complement? Is not a part. So what am I looking for? A complement are all the numbers that are not the multiples of 6. So if I look at 17, 17 is not multiple of 6. So yes, that belongs to A complement. 99 is not a multiple of 6. So that belongs to A complement. 37 is not a multiple of 6, so that belongs to A complement. But wait a minute, 24 is a multiple of 6, so that does not belong to A complement. It belongs to A. So that's going to be your answer. Let's look at another example. All right, let U be a set of all integers between -3 and +3, including -3 and +3. So what I do is I'll actually go ahead and write down my universal set. Remember, U stands for a universal set. So I'm going to go ahead and write that down. So I have U is equal to, in set notation, -3, -2, -1, 0, 1, 2, 3. All right, what about A? Set A is -2, 0, 1, and 3. Now they're asking me to find A complement. So give your answer in standard notation. The easiest way to do your A complement is simply write your universal set on top of your set, which is A, and then simply strike off. So I have a 2 here in A. That means I should not have a 2 there. I have a 0. I should not have a 0. I have a 1. I should not have a 1. I have a 3. I should not have a 3. So the rest of the numbers are complements. So let me go ahead and show you what the numbers are. So my -3 is A complement. My -1 is A complement. And my +2 is A complement. So if you look at it, what I did was I simply I striked off the numbers that are in A from the universal set. So whatever is remaining is my complement. So here, my A complement is -3, -1, and 2. Let's do one more example just to be on the safe side. All right, let's go ahead and work this problem out. Consider V. V is a set 2, 3, 5, 7, 9, 11, 13, 15, and 17. And they also gave me a P complement. And they said P complement be a set of either multiples of 3 or multiples of 5, excluding 3 and 5. So P complement does not contain 3 and 5. What they're asking me to do is to find set P. Remember how we find the complement? We simply strike off those elements from the universal set. The same concept applies here. So I'm going to look for the multiples of 3 and multiples of 5 and strike them out. So 2, that stays. 3, remember they said I cannot have 3 in there, excluding 3. So 3 stays. 5, excluding 5, 5 stays. 7, voila, 9 is a multiple of 3, so 9 is gone. 11, 13, 15 is a multiple of 5, so 15 is gone. So I'm excluding all the multiples of 3 and 5. And what am I left with? I'm simply left with the value 2, 3, 5, 11, 13, 17, and 19 as my set P. Now, if I look at the complement of this one, I will definitely have the multiples of 3 and 5. Given that universal set consists of all integers between and including 1 and 20, so I have a universal set U. So let me go ahead and write that down here. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And the set A consists of all the powers of 2, where n is a whole number, within the universal set. So how do I do that? I start with 2 power 0, which is 1, 2 power 1, which is 2, 2 power 2, which is 4. So you see the pattern here. 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, but this is way beyond this universal set, so this is not in my set. Do you see that? So my set A is all the powers of 2. When I rewrite it here, remember why I only stopped at 16? Because if I take the number 32, it's going to cross the maximum or the highest number in my universal set. So 1, remember anything to the power 0 is 1, 2, 4, 8, 16, and that's where I stop. And what are they asking me to find? Find the complement of set A. Find the complement of set A. So here, when I find the complement, remember what I do. I simply strike off all the elements in A from my universal set. So I have a 1 here. I will strike the 1 off. I have a 2 here. I will strike the 2 off. I have a 4. So strike the 4. 8. Right? And then 16. So my complement is all the numbers that I am left with, which is 3, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, and 20. So let's talk about union of two sets. The union of two sets, A and B, is a set containing all the elements in A or B. The union is, the notation for union is a U, A union B. More formally, X belongs to A union B if and only if X belongs to A or X belongs to B or both. But the key word here is, I would like to remember union, this little union, as U, and the key word is I simply combine. So that's the key word. Every time you see the word union, you blindly combine the sets. All right, let's go ahead and take a look at the example. So here I have the first example. I have let A is equal to 1, 2, 3, 4, 5. Let B is equal to 2, 5, 9, and 12. They're asking me to find A union B. Remember what union is? I'm simply combining both the sets A and B. All right, so when I combine them, I have 1, 2, 3, 4, 5. Remember, you're not repeating your elements. That is not how you write a set notation. So now I'm moving on to B. I already wrote down my 2. I already wrote down my 5. So the next one is 9. and the next one is 12. Remember, you do not repeat your sets, but you simply combine and make sure everything is in your set. All right, let's look at the next example. All right, let's look at the next problem here. Let A be a set of whole numbers bigger than 3 and smaller than 10. And B be the set of positive whole numbers smaller than 8. So what I'm going to do is I'm going to go ahead and write down my set A. My set A is whole numbers bigger than 3, smaller than 10. So 4, 5, 6, 7, 8, 9, and that's it. For B, the set is positive whole numbers smaller than 8. So positive whole numbers smaller than 8 is 1, 2, 3, 4, 5, 6, 7. I can't have an 8 in there because it has to be smaller than 8. Now they're asking me to combine both of these. All right, easy peasy, right? I simply put them together, starting with the smallest number, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Remember, union is simply combining both the elements and making sure you are not repeating the elements. All right, now let's look at intersection. A quick recap. Remember what union was? So when I say A, let me move my mouse right here. So when I say A union B, you are simply combining. So your keyword is to combine. But what we're going to look at right now is A intersection. That means you're finding something common between both the sets. So what does intersection mean? Intersection of two sets A and B is a set containing only elements that are in both the sets. And how do you represent that? The notation is A, inverted U, and B. All right, let's take a look at the examples. And the keywords are union is combine and intersection is common. All right, let's start with this problem. Let A, I have pear, orange, pineapple, banana, apple, and B, spoon, orange, knife, fork, apple. They're asking me to find A intersection B. So I'm trying to find something that is common. So when I look at it, I have an orange common in both of them, and I have an apple common in both of them. So my A intersection B is simply orange and an apple. It's as simple as that. All right, let's go ahead and do one more. Let P be the set of integers that are multiples of 3 between 1 and 20. I always like to write them down because I'm a visual learner. So I'm going to go ahead and write set P. Multiples of 3 between 1 and 20. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. I can't go beyond 20. Q is the set of even natural numbers up to 15. So even 2, 4, 6, 8, 10, 12, and 14. Remember what they're asking me? They're asking me to find something that's common between both of them. So when I look at that, I have a 6 that's common, and I have a 12 that's common. So always write down your sets. That way you can actually see what your sets are. So A intersection B, in other words, I'm asking what's common between both of them? What are they sharing together? They're sharing the numbers 6 and 12. All right, so the last problem is let X be A, B, C, and Y is an empty set. So let me write that down here. So X is A, B, and C, and the set Y is absolutely nothing. They're asking me to find what is common between these two. What do you think is common? Absolutely nothing. So it's empty, there's nothing common. So you represent nothing or an empty set with a circle and a slash. That's called the empty set. All right, if you have any questions, please make sure you contact me with email or Teams. Hope this helps.